Venus is one of the most unique planets in the solar system. Despite being almost the same size as Earth, it has an extremely dense atmosphere, and the surface is hot as hell. In its clouds, there are acid rains that evaporate at a height of several kilometers, and the surface is covered with a supercritical fluid of liquid carbon dioxide. Hello, this is the Epoch of Mistrust with you. We've already talked about many oddities of Venus, but we've bypassed one of its main peculiarities, the retrograde rotation around its own axis. Now we will dedicate an entire video to this phenomenon, and at the same time, we will find out how so much carbon dioxide, sulfur, and why its surface is covered with lava, and much more interesting. As usual, we will deviate from the official version in using known physical laws and rules of our universe. First, it is necessary to understand why the reverse rotation causes confusion at all. And for this, it is necessary to understand why planets rotate around their axis at all and how they actually came to this. It all started many years ago, millions of years, possibly billions. In the infinite spaces of the universe, on the edge of our galaxy, nothing foretold trouble. Space peacefully fluctuated, giving birth to virtual particles from nothing. These particles behaved unpredictably and appeared here and there, in pairs, and having played with their own spin, they disappeared into nowhere just as suddenly. Perhaps for this reason, or maybe for some other unknown one, the interstellar gas lost its uniformity, as a result of which its denser and thicker places began to attract the remaining solitary molecules. Long or short, but the accumulation of molecules became increasingly massive. And now it already has its own center of gravity and gravitational field, although it is still gas. Becoming more and more dense and increasing its gravitational field, our object attracted more and more gas with increasing speed. And soon the speed of the flow of matter reached such a threshold at which the incoming molecules were already able to slip by. Just like our satellites now, or the International Space Station, which thanks to their speed do not fall to Earth, as if slipping past it. A rotation around the common center of mass appeared. With the appearance of rotation, and not without the help of centrifugal and centripetal forces, the gas cloud, each molecule of which sought to occupy the most comfortable orbit, gradually flattened, acquiring the shape of a rotating disk. A protoplanetary gas dust disk began to form, rotating in a single burst around the still-forming protostar. In the gas dust disk itself, processes were also underway. In the space, and it also began to collapse, that is, to shrink in space. And it also began to collapse, that is, to condense into large chunks of matter, forming planets. And the most unpleasant thing, the outer side of the protoplanet was spinning faster than the inner one. It was this remarkable fact that gave a rotational impulse to all the planets in the same direction, counterclockwise. In such a cunning way, the immutable laws of motion within the solar system were formed. And everything would be fine, but a couple of planets with the slightest deviations regularly violate these rules. One of such planets is Uranus, but now it doesn't interest us. But the second one is our favorite, Venus. It's almost the closest planet to the Sun, if you don't count Mercury. And then the opposing forces, solar gravity, the difference in speeds between the inner and maximum force. That's why the fact of Venus's retrograde rotation sounds like a maximum force. That's why the fact of Venus's retrograde rotation sounds like a mockery of common sense. as if someone deliberately put the most impossible of all states right under our noses. So we have, first, the laws of rotation of the solar system. This is a fact. Second, the fact in physics and in general scientists on this matter. One of the physicists and in general scientists on this matter. One of the first theories was expressed back in 1956 and suggested that during the early period of Venus's development, a large asteroid embedded itself in it. And the force of the impact was so great that the planet began to rotate in the opposite direction. However, the theory did not pass the mathematical calculations test. Mathematics showed that an impact of such force should have simply torn the planet apart, so this theory was abandoned. It simply turned over, but they couldn't explain such a process, how it happened. Although some strongly assert about solar gravity as tidal forces, but the mechanism of the process is still unknown. Another theory asserts that Venus was spun in the opposite direction by its own atmosphere. There are several other theories, but they all suffer from the same flaw: they can't be modeled. Nevertheless, the already voiced versions were as close to the solution as possible. Let's try to model and understand what went wrong with the scientists. So, the first version, meteorite strike. For modeling, we'll first use the already known open program of the Imperial College London for calculating the consequences of a meteorite collision with Earth. Yes, unfortunately, you can't choose another planet here, but essentially it doesn't matter to us. We will match the Earth and the asteroid in terms of size and direction of movement. The asteroid will be comparable in size and direction of movement. We won't be penny pinching, so we'll take a rock 500 kilometers in diameter right away, give it a fantastic speed of 70 kilometers per second, and send it to meet Earth at a shallow angle of 10 degrees. Among the consequences that interest us is a slight change in the Earth's rotation speed, approximately 17 minutes, but the rest is some kind of nonsense. The orbit does not shift, and the tilt of the axis also remains in place. That is, in response to such a powerful blow, the consequences in our case are more than negligible. Let's increase the size of the projectile and hit the Earth with the Moon. The effect here is slightly stronger. The length of the day will change significantly. And with this, 22% of the planet will become molten. This is serious. However, the orbit and axis do not shift again. Although no, the axis shifted, but only by half a degree. But we need not half a degree, but 177 degrees. That is almost 350 times more. Therefore, before moving on to another simulation, let's ask the last question. And what if we collide Earth with another Earth exactly the same? Yes, Earth is completely destroyed and formed a new asteroid belt. So we clearly saw, based on mathematical calculations, that changing the axis with the help of an asteroid or comet strike, any, I underline, any size, will lead to nothing. Well, unless the planet is destroyed. Apparently so, or it won't lead to that. Well, unless the planet is destroyed. Apparently so, or rather, this tool has one significant downside. It cannot indicate the direction of the asteroid's movement, from which side and into which part it will hit. By default, the rules are taken into account for the result, but more than 70 years have passed since then. Surely not the result, but more than 70 years have passed since then. Has nothing really changed, and is this theory finally dead? Judging by the fact that they try not to return to it, yes. However, we will not stop at this and will try to model the action again, but this time more clearly and using a more modern and perfect simulator. Our task is to achieve a significant axis tilt, for example, degrees to 100, without destroying the planet itself, as we already know changes or will destroy the planet. Let's try to reproduce such a blow on a new one, no changes, or will destroy the planet. Let's try to reproduce such a blow on the new simulator. First, let's take a meteorite 20 kilometers in diameter and slam it into Venus with all our might. But before that, for the sake of experiment purity, let's set Venus's axis to 0 degrees. After the head-on collision, the axis shifted less than 0.4 of a degree from 0. About nothing. With 2,000 kilometers at the collision, it produces almost the effect we need. Here, take a moment. Before taking a moment. Upon collision, Venus instantly changes its axis by 175 degrees. That is practically exactly as we need it. Remember, its axis tilt is currently 177 degrees. So, after all, a collision with an object 2,000 kilometers in diameter gives us the effect we need. And yet, the planet will not be destroyed. And yes and no. First of all, we launch the object deliberately, straight on a trajectory that is unlikely in the solar system. That is, clockwise, opposite to the direction of the planet's rotation. Secondly, we forcefully started the rotation in the opposite direction at a high speed. One rotation takes 4 Earth days. If we launch this object according to the rules, then the impact will not stop the planet's rotation, but rather accelerate it. But as an option, let's still remember it. It might come in handy. Now let's try to conduct the experiment a little differently. Let's make the size of the bullet 500 kilometers in diameter. Not 1, but 20 pieces at once. One after another as it happened. As you can see, the planet has retained its integrity and the axis has shifted as much as 30 extra degrees and 177 degrees in total. There's very little left. So if we add another 50 or so similar impacts, the planet's axis is likely to flip and it will start rotating in the opposite direction while maintaining its integrity. But why is this option better than a single collision with a mega boulder? Well, for one, the actual rotation in the opposite direction in this scenario takes almost 2 months per rotation. This is much closer to reality than a single strike. Secondly, the planet is guaranteed to maintain its state, its integrity. Although in the third place, in a melted state. Fourthly, the picture itself is complete. Although in the third place, in a melted state. Fourthly, the picture itself shows traces of large objects falling into the molten mass. That is, if the impact was solitary, then the planet would simply have melted and then solidified with a perfectly smooth surface, unless it would have been shattered. They are formed precisely when large objects fall into a semi-liquid mass in a molten state. And it is precisely such a picture that we observed when in a molten mass. And it is precisely such a picture that we observed during the simulation with 20 asteroids. In addition, the multitude of small asteroid impacts adds so much energy to the planet that its entire surface heats up to almost 2,000 degrees. In the process, everything on the surface burns, generating massive amounts of carbon dioxide. Titanic impacts eject beyond the planet's boundaries also a large amount of sulfur. Not only through volcanoes, sulfur ended up there. In fact, it simply cannot settle back on the surface now. Sulfur compounds simply evaporate back into the atmosphere, not flying a couple of kilometers to the surface. And now the planet is drying out. Simulations show that it has only about 600 to 700 years left until it cools down acceptably. And that's if we don't help it in any way or interfere with the process. For example, increasing the albedo, or reflectivity, by just 5 to 6% significantly speeds up the cooling process. The presence of sulfur in the atmosphere is very significant in this case. Thanks to it, Venus now has an albedo of almost 80, meaning 80% of the solar radiation is reflected. About the influx of unknown reflective substances into the atmosphere. Could someone really be causing an influx of unknown reflective substances into the atmosphere? Is someone really interfering? Moreover, it can be assumed that after some time, hundreds, maybe thousands of years, Venus's rotation in the correct direction will also be restored, just like the rotation of the moon. Also, the recent collision explains the paradox of a young planet. I remind you that due to the extremely hot surface, many astrophysicists consider Venus a young planet. Indeed, in their opinion, this is how the planets of the solar system should have looked at the dawn of their formation. At the same time, for some reason, no one is bothered by the fact that the solar system itself would now be not 4 billion, but 40 years old, and you would already be a fully formed independent man, but suddenly a third leg began to grow on you, moreover, a female one. The active bombardment of asteroids is confirmed by the planet's radiolocation images. It is literally all in the traces of the impact of cosmic bodies. But if this is true and Venus has recently undergone such an orbital bombardment, then other questions arise. For example, there should be historical mentions of this fact. Well then, allow me. 646 years. Astronomer from Naples, Francesco Fontana, observing Venus through a telescope, also observed several of its satellites. Two very curious moments in his observations. Firstly, he discovers Venus's satellites moving in a non-standard trajectory along a polar orbit. Secondly, the satellites are not just accompanying Venus. They are literally rolling across its surface from south to north, from one pole to another. In addition, the size of these satellites, judging by the fountain's drawings, is approximately 1.5 to 2,000 kilometers in diameter. In addition, he claims that Venus emits multiple rays, and the satellite itself is slightly reddish. However, other astronomers could not confirm his observation, so no one believed him. In particular, the director of the Venusian observatory noted that the rays of light that Fontana observed around Venus are highly suspicious. Moreover, when these rays were not present, Fontana could not see the satellite. And probably he had poor optics, and he was observing some atmospheric phenomenon. However, if we still believe the astronomer and assume that some large object was moving across the surface of Venus, then by itself it was heating both itself and the surface to the state of magma, hence its reddish color. And the mysterious rays are the ejections of molten rock into nearby space as the object moves. And in itself, such movement could not continue for long. The object would inevitably and very quickly collide with the planet. Therefore, by the time the news was published, other astronomers could no longer see it. And although this seems very much like fantasy, but just 30 years later, in the year 1672, and then in the year 1686, another much more respected and famous astronomer, Giovanni Cassini, observed similar phenomena. In the description, he says that the size of the object was 1/4 of the diameter of Venus, and it itself was located from it at a distance of 3/4 of its diameter. Translating this into normal language, the satellite had a diameter of about 3,000 kilometers and was located only 9,000 kilometers away from it. In other words, it was entirely within the so-called Roche limit, where all objects are torn apart by tidal forces and fall to the surface. That is, it was a different object, but one that had appeared near Venus quite recently, and its lifespan would be measured in months, if not days. Here are already two huge objects that have fallen into Venus's gravitational field literally in 30 years. And both of them definitely fell on Venus, heating its surface to the highest temperature. But the observations do not end there. 60 years later, in the year 1740, a British astronomer and renowned telescope maker published in the Philosophical Transactions of the Royal Society of London about how he observed Venus's satellite, which he initially mistook for a star. The size of this satellite was about 4,000 kilometers in diameter. However, he very quickly began to deny everything and even wanted to renounce his observations. Despite this, the news had already gone out into the world, and it was impossible to keep his discovery a secret. Another 19 years later, in 1759, Andreas Meyer observed a sphere for an entire hour at a distance of approximately 3,728 miles next to Venus. The size of the sphere was approximately 2,000 kilometers in diameter. However, Meyer recorded the following very carefully in his diary. Future observations will show whether this was a small sphere of optical illusion or a satellite. So this is already the fourth object that has entered the Roche limit zone at Venus. In itself, it also could not exist for long. We also see that by that time, the presence of satellites around Venus had apparently become a taboo topic because a professional astronomer who had been observing the object continuously for an entire hour still allowed that it could have been an illusion. Whether it was a rush to facts or just caution, in the first year, two well-known astronomers, Louis Lagrange and Jacques Montaigne, saw Venus's satellite again. Jacques Montaigne observed this object for a whole week from May 3rd to 16th of the first year, and he made sketches from which it can be seen that this satellite has a size of about 2,000 to 3,000 kilometers in diameter and moves in an elongated elliptical orbit, which is also polar. The minimum distance to Venus this time was about 25 to 30,000 kilometers. Besides Venus, there's an asteroid passing by. At the same time, there was an attempt to pass by Venus, the passing asteroid. At the same time, an attempt was made to calculate the parameters of the satellite's orbit. The first calculations gave a rotation period of 9 days and 7 hours. But the next calculation showed a different period of 12 days. That is, the orbit was also unstable. After this, the object's orbit was also unstable, and after a couple of rotations, the satellite's orbit was still unstable. And after a couple of rotations, the satellite still went beyond the influence of Venus and broke away from it. Where it is now is a mystery. Possibly it joined the group of Apollo-class asteroids orbiting close to the Sun. Or maybe it broke into pieces. Half a century later, in the year 1884, a new satellite was spotted by Friedrich Arc. Nevertheless, by the end of the century, the interest was noticed by Friedrich Arc. Nevertheless, by the end of the century, interest was difficult, and perhaps also because one after another, several well-known astronomers of that time, for example, Hell, persistently asserted, and the drawings explaining the emergence of this phenomenon. At the moment, there are many drawings explaining the emergence of this phenomenon. At the moment, there are many versions from optical illusion to the destruction of a satellite in a century or another planet closer to the Sun than Mercury. However, the most interesting things started during the space flights to Venus. Not a single modern flying apparatus found any hint of the existence of the satellite. However, a thorough scanning of the surface of Venus was carried out, thanks to which we received a fairly detailed image of it. We observed craters, plumes, and lava rivers. But the most interesting are the mysterious poles, traces, as if driven by some massive body, passing through the entire planet from one pole to another. Such a trace could be left by one of the satellites, fixed by Francesco Fontana or Giacomo Montanem. They had exactly such trajectories. Thus, the fantastic theory about the orbital bombardment of Venus over the period from the 17th to the early 19th century takes on a realistic outline. But there is one very delicate weak point in this theory. The thing is, a planetary collision is a rare, unique event that happens once in a million, maybe even 100 million years. And by accepting our hypothesis, we assert that for some 20-odd years, Venus has withstood collisions with at least a dozen such objects. And these are just the documented collisions. In reality, there should have been many more, and much more frequently. Perhaps it's this very point that makes scientists reject such a course of events. But what if I told you that there are natural mechanisms capable of causing such a light show? And what if I told you that they are also fixed in documents? Moreover, there is confirmation of this in our solar system. A huge amount of facts that literally scream about this. But about this in one of the following episodes. To be continued. Subtitles created by